We will study about the definition of one AMU and how to convert atomic mass of any atom to the AMU scale. Now, generally, atomic mass are written in terms of relative atomic mass. So, the fact is that atoms are so small that atomic masses are actually very small quantities. So, now there are various modern advanced techniques to measure atomic mass in an accurate way. But previously, in older times, there were no such technologies. So, scientists used to measure the mass of an atom in terms with each other, that is, in terms of some reference atom. So, the atomic mass that was measured was actually the relative atomic mass, which was measured like they considered one atom as the reference and the masses of other atoms were measured with reference to that. So, the first concept was that hydrogen is the lightest atom. Okay. So, it was assigned the mass of 1. So, previously all atoms were measured in terms of hydrogen. Okay. Were measured relative to the mass of hydrogen. But in the present times, atomic masses are calculated in terms of carbon-12. Carbon-12, okay. So, we can write carbon-12 as this. So, we had discussed that we write atomic mass on the top. So, this is carbon-12. Carbon-12 is the isotope of carbon which has a mass of 12, which is assigned a mass of 12, okay. So, carbon-12 is assigned a mass of 12 AMU. Okay. So, relative atomic mass is the ratio of the mass of an atom with respect to 1/12 of the mass of carbon-12. So, the definition of relative atomic mass. So, relative atomic mass is the ratio of the actual mass of an atom with respect to 1/12 of the mass of carbon-12. Okay. So, atomic mass unit arises from the definition of relative atomic mass. So, relative atomic mass is the ratio of the actual mass of an atom with respect to 1/12 of the mass of carbon 12. So, the AMU we were talking about here, AMU means atomic mass unit. Okay, atomic mass unit is written as AMU. So, the definition of atomic mass unit. Atomic mass unit or AMU is defined as a mass exactly equal to 1/12 of the mass of one carbon 12 atom. Okay. So, atomic mass unit or AMU is defined as a mass exactly equal to 1/12 of the mass of one carbon 12 atom. Okay. So, 1 AMU is equal to 1.66056 into 10 to the power minus 27 kg, which is equal to 1.66056 into 10 to the power minus 24 grams. This is the relation between 1 AMU and kg. That is the SI unit of mass. So, mass of 1H, that is hydrogen 1 atom, this can be measured as the actual mass of hydrogen 1 atom is 1.6736 into 10 to the power minus 27 kg. So, in AMU scale, this is 1.6736 into 10 to the power minus 27 kg divided by 1.66056 into 10 to the power minus 27 kg. This comes as 1.0078 AMU. Okay. So, the mass of hydrogen by convention is considered to be 1 AMU. So, 1 AMU can also be defined as, the actual definition of 1 AMU is 1/12 into the mass of one atom of carbon 12. So, 1 AMU can also be written as 1 into mass of one atom of hydrogen 1. This can be explained in terms of any elements as we wish. So, we can write 1/16 of the mass of one atom of oxygen 16 and so on. So, this is the actual definition of 1 AMU, the relative mass of an atom is equal to mass of one atom of the element which is to be considered divided by 1/12 of the mass of carbon 12. Okay. So, the relative mass of an atom of any element is given by the actual mass of one atom of that element divided by the 1/12 of the mass of 12 carbon. Okay. So, by this method, mass of oxygen 16 in AMU scale is 15.995 AMU. Mass of nitrogen 14 in AMU scale is equal to 14.003 AMU, and so on. Now, in the recent times, AMU has been replaced by U. Okay. U is unified mass. So, this was about the relative mass of atom. Now, the question is, why carbon 12 is chosen as the reference? Any other element can also be picked. So, why carbon 12? Why carbon 12 is considered to be the reference atom? Okay. So, there are a few points. The first point is natural abundance of carbon 12 is high. Okay. The second point is reactivity is low. So, carbon 12 is not highly reactive. So, we can easily use it for measurement. The third point is by using carbon 12 scale, atomic masses of maximum elements can be made in whole numbers or nearly whole numbers. So, the first point is that carbon 12 is naturally abundant, that is, it is present in nature in high amounts, its reactivity is low, and by using carbon 12 scale, atomic masses of maximum elements can be made in whole numbers or nearly whole numbers. Okay. So, these were the reasons why carbon 12 is considered to be the reference atom. So, let's do one numerical. So, the question is, if an atom has a mass of 3.351 into 10 to the power minus 26 kg, find out the amount of nucleons in 3 atoms of this element. Okay. So, the mass of an atom is given as 3.351 into 10 to the power minus 26 kg. Find out the amount of nucleons in 3 atoms of this element. Okay. So, we need to find out the amount of nucleons, that is the total number of protons and number of neutrons. Okay. So, A is equal to number of nucleons, which is equal to the number of protons plus number of neutrons. We need to find out the atomic mass in AMU scale. So, A in AMU is equal to the actual mass, that is 3.351 into 10 to the power minus 26 kg, divided by 1 AMU is equal to 1.66056 into 10 to the power minus 27 kg. We can write this term as 33.51 into 10 to the power minus 27 kg divided by 1.66056 into 10 to the power minus 27 kg. Okay. So, this comes as, so we cancel these two. So, this answer comes as 20.2, which is equal to 20. So, the mass number here or the total number of nucleons is 20. So, we are actually talking about the neon atom. Neon has an atomic number of 10 and a mass number of 20. So, if one atom of neon has 20 nucleons, one neon atom has 20 nucleons. So, 3 neon atoms, we need to find for 3 neon atoms, right? So, 3 into 20 equal to 60 nucleons. So, in the next lecture, we will study about the average atomic mass and we will do some numericals on it. Thank you.